What is the effect of different levels of acidity on chalk? By Sydney Seifert, West Potomac High School. What is known/already been done? Acid rain can occur in many different forms, such as snow, fog, rain, and tiny bits of material that settle to Earth. Acid rain normally has a pH between 4.2 and 4.4, and acid rain is caused by sulfur dioxide and nitrogen oxides being released into the atmosphere. These emissions are then transported by rain and air currents, causing the sulfur dioxide and nitrogen oxides to react with oxygen, water, and other chemicals. As a result, this forms sulfuric and nitric acids that then fall to the ground after they've been mixed with water and other minerals. In addition to this, we also know that acid rain causes calcite and limestone to dissolve. My hypothesis for this experiment is the more acidic a liquid is, the faster it will completely dissolve in the chalk. What did I do/how did I collect data? For my different steps, I had 1. Set out 3 beakers. 2. Label each beaker properly. 3. Put on safety equipment, such as gloves and goggles. 4. Measure acids equally and put each in their designated beaker. 5. Set timers next to the designated beaker. 6. Drop 1 stick of chalk into each beaker and start the timers. 7. Stop timer for each beaker once chalk is fully dissolved. 8. Once all are done, record data. 9. Clean up properly. I repeated this 3 times. I collected my data using Google Sheets to store my data and observations. To record my data, I used Google Sheets, but for your convenience, I translated it onto this in a table. For liquid, I put tomato juice, lemon juice, and water underneath that section. For tomato juice, all my trials were 16 minutes, as well as for the other trials I did for all the other liquids. When I did the tomato juice, my observations were that I started to see bubbles come up after I put the chalk in, and white bubbles formed at the top of the liquid, which I assumed came from the chalk. My second liquid I used was lemon juice. I observed that the chalk made a hissing sound when I first put it in, when I placed the chalk in the beaker with the lemon juice in it. My third liquid was water, and I observed throughout the whole experiment that small bubbles were coming up from the water the whole time. These are my results continued. These are my observations from when I put the chalk in the lemon juice. When I first put the chalk in the lemon juice, the chalk made a hissing sound, which I thought was quite interesting. In addition, over the duration of the time that the chalk was in the lemon juice, small bubbles would occasionally come up. Once I took the chalk out of the lemon juice, I observed that the chalk looked slightly discolored, almost a yellow color, slightly. When I observed the tomato juice in the chalk in the tomato juice, I placed the chalk in tomato juice. It immediately started to bubble. Over time, foam-like bubbles appeared at the top of the tomato juice, which were white. After I took the chalk out of the tomato juice, the chalk had been stained a yellowish-red color from the tomato. When I put the chalk in water, I observed that the chalk did not make many changes, but over time it looked like air bubbles occurred, and bubbles would come up. It only looked slightly discolored, unlike the others. My interpretation of my result was that the results support the fact that acid rain damages limestone and that different acidities do affect chalk, which research I did before I did my project supports. Some possible errors that could have occurred during my project was that the chalk sticks could have possibly been slightly different sizes, which could have affected how they reacted because there could have been breaks in them or something. And another thing is that I was unable to observe the chalk in the lemon juice fully because the lemon juice was kind of cloudy, so I couldn't really tell what was going on inside of it, unlike the others. The tomato and lemon juice being colored also could have affected how the chalk looked afterwards, so I can't be sure if that caused the discoloration and if it will look as discolored as the water, if it was just clear. Also, another possible error was that I originally planned on leaving my chalk in the tomato juice, lemon juice, and water and seeing how long it would take for it to fully dissolve. However, during my experiment, I realized this would take multiple days, so I decided to leave my chalk in different liquids for 1 hour instead, which could have screwed up my experiment. These are the conclusions I reached during my project. In the context of the literature review and other work being done in my research area, my studies and data show that acid rain is a real problem and it does have a negative effect on limestone. These results gathered address my research questions by showing that acid affects chalk by discoloring the chalk and also creating bubbles as a reaction to different acids, again, supporting that acid rain does affect limestone negatively. This does not support my hypothesis since I ended up having to take the chalk out before it had fully dissolved, since I was originally going to keep it in for as long as it took to dissolve, but I ended up just taking it out after 1 hour. This can be applied in the real world to help prove acid rain does affect limestone negatively. These are all the references I used throughout my project and to complete this slideshow with. Thank you.